Today's lesson is on sequences, and we'll begin by just a quick introduction to what we've learned before about sequences, and then go on to try and work out the nth term, any term in any arithmetic sequence. So the learning objectives for this lesson are primarily recognize a pattern in a sequence of numbers, which is a bit of revision really, and the main purpose, which is to predict the nth term in a sequence. We'll review a simple arithmetic sequence then. The following is an arithmetic sequence: 4, 8, 12, 16 and 20. So we should be able to predict the next number in this sequence if we know what the rule is for generating each number in the sequence. So the rule is what to generate each number in the sequence? Well, yes, we add 4. 4 goes to 8 by adding 4, 8 to 12 by adding 4, 12 to 16 by adding 4, and so on. So we should be able to predict the next number in the sequence is 20 plus 4, 24. What we're going to do now is try and draw up the mapping diagram for the sequence. And to do that we need to draw up a little table. In the first column of the table we're going to put down the term number, what we'll call n. And then we're going to put down the term value, what its actual number is, in this case 4, 8, 12, like this. Term number 1 is a value 4. Term number 2 has a value 8. Term number 3 has got a value 12. Term number 4 has got a value 16. We can see a pattern in these numbers in terms of what the term is and how we're using the rule add 4 to generate each value. So for example, for the first row here, 1 times 4 will give me 4. For the second one, I take the second term 2 times it by 4 to get 8. For the third one, I take the third term value 3 times it by 4 to get 12, and so on. 4 times 4 is 16. So what would I get if I had term number 10? Well, again, using the same rule, 10 times 4 would give me 40. Now I should be able to go on and predict any value, let's say n. What am I doing to get the number? I'm taking the term number and multiplying it by the number 4. n times 4 is what I'm going to get, which in simple terms is 4n. So I have a way of predicting the value of any term if I know the term number. And what I've been using here is the rule add 4. I'm actually using the 4 times table. 4 times 1 is 4, 4 times 2 is 8, 4 times 10 is 40, and 4 times n is 4n. And so I've come up with a rule that if I want to work out the value of any term in this sequence, I take the term number n and multiply it by 4. Let's explore this idea a bit further. I've got a new sequence here, 3, 5, 7 and 9. To get from 3 to 5, I've had to add 2. To get from 5 to 7, I've added 2, and so on down the sequence. So I should be able to predict the next term. The fifth term in the sequence will be 9 plus 2, 11. So this is a very simple sequence. The simple rule is add 2 to the previous number to get the next number. Using this number we can work out the next number in the sequence, which will be 11. Let's look at this a little bit deeper. I've got the term values 3, 5, 7 and 9. I've got the term numbers 1, 2, 3 and 4, and I'll refer to them as that, term number n. I want to be able to predict any number in the sequence. Let's say, for example, I wanted to predict the 40th term in the sequence. How would I do it? Well, I can do that now by simply adding 2 to each term until I get to the 40th term. And that'll take a while. 9 plus 2 is 11, 11 plus 2 is 13, 13 plus 2 is 15, and eventually I'll get to the 40th term and find out its value that way. But actually I want to be a bit cleverer than that. I don't want to work out all the terms in between to work out the 40th term. So how do we do it and keep the calculation as simple as possible? Well, the answer is we need a better rule. We know from our numbers at the top that we're adding 2 each time to the previous number, and that gives us a clue as to how we might approach this. It looks like we're using the 2 times table. So let's take this a bit further then. We're going to draw up a table like this with 4 columns. In the first column we're going to have the term number n. Then we're going to have something called the times table. We'll come back to that in a second. Then we've got a column called plus or minus, and again we'll come back to that in a second. And then we end up with the actual term values, the numbers we see above, 3, 5, 7, 9, etc. We're going to put in the term numbers first then. Here they go. Now we'll put in the values for those terms. And they'll go in like this. I want to know the 40th term without working all the numbers out in between. Now I'm going to assume that we must use the 2 times table since we're adding 2 to each number in the sequence. In other words, I'm going to put into this column here times 2 to indicate the times 2 table. Now I'm going to multiply the value of each term by 2 and place the result in the second column, the times table column. So 2 times 1 is 2, 2 times 4 is 4, 2 times 3 is 6, 2 times 4 is 8, and 2 times 40 is 80. Now, if we compare the value in the times table column, 2, with the value in the final term value column, 3, we notice a disparity. They're not the same. We should have a value 3, we've actually got a value 2. So what must we do to the value in the times table column to get the value the same in the term value column? Well, the answer looks like add 1. So let's do that. We'll add the 1 in, and we'll do it for all the values in the rows. So we end up with the correct value in the term value column. So we should be able to predict now what the 40th term will look like, what its value will be. It's going to be times 2 to get 80, and add 1 to get 81. So now we can ask ourselves the question is, what might be our rule to work out the 40th term or any term? The value of any term seems to be twice the term value plus 1. So let's call our any term just n, and the value of any term is going to be twice the value of the term plus 1. Now let's see if we can predict the 100th term. Remember that any term n can be found with the rule 2n plus 1. The 100th term therefore is twice the 100 that comes from the n plus 1. So our result is going to be the 100th term is 200 plus 1, or 201. Easy peasy. Let's try one more example. Here's our sequence 4, 7, 10, 13, and so on. We begin by asking ourselves again, what's the rule to get from 4 to 7 to 10 to 13? And the rule is add 3. So it looks like in this case we're going to use the 3 times table to help us work out any term in the sequence. For that we're going to need another mapping table, and we'll keep this one simple, just down to 2 columns. Let's put down the term number and the term values for the ones we know. Now I want to work out what is the rule to get from term 1 to value 4, or term 2 to value 7. Now bearing in mind we're adding 3 each time and we're going to use the 3 times table, it looks like we're going to take the first term, multiply it by 3. Well, 3 times 1 will give me 3, but that isn't 4, it's short by 1. It looks like I need to add 1, something like this. 3 times 1 plus 1. Let's look at the second term. 3 times 2 will give me 6. 6 is short of 7 by 1, so it looks like it's 2 times 3 plus 1. And we'll carry on down this table in a similar fashion. Now what about the 10th term? Well, if we apply the same rule, it's going to be 3 times 10 plus 1. 3 times 10 is 30, plus 1 will give me the answer 31. Now, can I make this more generic? For any term n, what will be the rule and what is the value for that term? Well, the rule is going to be 3 times n plus 1, or n times 3 plus 1, which will end up looking like 3n plus 1. So the rule is the value of the nth term is 3n plus 1. Now use this to predict the 50th term. The 50th term will be 3 times 50, because it's a 3 times table, plus 1. And that'll give us the result that the 50th term is 151. 3 50s are 150, plus 1 to get the 151. And all this springs from the fact that I'm adding 3 each time to my number in each part of the sequence. This leads me to believe I'm using the 3 times table. That in itself is insufficient. To get the final term value, I need to add 1. And that's the rule I've ended up with. The value of any term is dictated by the rule 3n plus 1, where n is the number of the term. Easy peasy.